civilization's pipe dream. Surging with life-giving water and tons of waste. Feeding the fixtures that spoil us and flushing us with pride. Its potential is explosive and its history overflows with innovation. Now, plumbing on Modern Marvels. If there's one fact of life we all hold in common, it's our dependence on water. Regardless of race, creed, or social status, we all rely on it for our very survival. We've been depending on the craft and science of plumbing for thousands of years, as it enables us to bring fresh water where we need it and take dangerous wastewater away.
Even though we kind of become complacent in the industry in so much as what we do every day, we kind of lose sight of the fact that the plumber is a very important part in the health industry. We don't have the outbreaks of diseases. We don't have any of the things that we had as little as 100 years ago or less.
Throughout history, the ability to control water has been one of the defining elements of a sophisticated culture.
Plumbing is civilization. Just about every civilization that we look back on in antiquity, that we study and admire for their contributions to art and literature and science, technology, civil order, also were highly developed plumbers.
Early concepts of plumbing, mere ditches in the ground, have developed into complex networks of pipes capable of supplying water to cities of millions. Ever wondered how much plumbing pipe you've got in your home? The average American house has over 700 feet hidden between the walls and under the floorboards, allowing everyone in the house to consume more than 50 gallons of water per day.
Whenever somebody thinks of a plumber, they think of the guy that came and fixed their toilet and charged too much. But it's quite a mechanical trade with a great deal of skill and a great deal of knowledge involved in it.
To reach the fixtures that place it at our fingertips, water is often transported hundreds of miles from its source, above and below ground. Once it reaches the city, thousands of miles of underground water mains carry it into buildings, where water flows hot and cold at our beck and call. One universal force of nature drives the water from point A to point B and maintains pressure in the pipes: gravity. Water is pumped to the top of giant towers, which are connected to the mains beneath the streets. As long as the tower is higher than the water's final destination, gravity will maintain pressure and force water through the pipes. In buildings that are taller than the water tower, water is pumped to a series of pressure tanks inside, each using gravity to feed the floors below it. After water is used, gravity once again carries it away. Sewer pipes are built at an angle so that wastewater can flow downhill. After sewage has been treated, it flows by gravity into the nearest waterway, where it's reclaimed by the earth. Mastering the basics of plumbing across the centuries has allowed us to take the art and technology of the craft to new levels. We've got fixtures to pamper us, and fixtures that conserve water. Some elaborate systems pump water to the tops of 100-story skyscrapers, while others convert salty seawater into drinking water. State-of-the-art plumbing is even snaking its way into America's growing number of new sports arenas. San Diego's Petco Park boasts an array of plumbing advances that meet all the needs of 42,000 baseball fans.
The project contained over 200,000 feet of pipe, which is approximately 38 plus miles. There are approximately 30 point-of-use electric water heaters, approximately 520 toilets, 225 urinals, and approximately 450 lavatories.
Engineers designed the park's vast plumbing network not with blueprints, but with computer-assisted drawings, or CADs.
The CAD drawing system that we use expedites the drawing process. Rather than using the traditional, what we call stick drawing, he can pull that up on a CAD drawing and he can see the background of all systems. He looks at that for coordination. It allows him to see where the walls are, where the structure is, confirming that we don't have a duct line and a water line or a sewer line in the same location.
All the water that the stadium uses for everything from its fountain and concession stands to field irrigation and firefighting first passes through here, the heart of the plumbing system.
We are in the domestic water booster pump room. This is where the incoming water comes from the city. The water is boosted in pressure with a triplex pump system. This is to compensate for any variables in city water pressure to keep a constant water flow to the building itself.
Huge pumps also regulate water flow once it's in the stadium complex. This ensures that even during the seventh inning stretch, when 40,000 fans just might use the bathrooms all at once, water pressure remains uninterrupted.
When there's a demand for the water upstairs from the toilets being flushed and the sinks being used, this system will sense that and turn on the first pump, but not at the full operating level. This box is a computerized system inside. It actually has a little CPU inside that has sensors throughout this system to make it operate.
Before the stadium opened, plumbing contractors tested this high-tech system using a method any fraternity prankster would salute. Hundreds of volunteers stationed themselves throughout the stadium's restrooms for a super flush. At a signal, they would simultaneously flush almost all of the 520 toilets. To simulate the moment of maximum water usage during a game.
The reason for the super flush is to make sure that the plumbing system works per design. And what we're talking about is to make sure that when we have a seventh inning stretch, when most people use the restrooms and go use the concession stands, the water usage is usually at its peak volume. And we're assuring that the pipe sizes and the sewage system will operate properly. And it actually went very well. And we had no backups, no overflows, and it was over quite quickly.
The only thing more reliant on Petco's plumbing system than the fans is its lush manicured turf. 85 powerful sprinklers, divided into 19 watering zones, spray the 110,000 square foot playing field.
On the average, this head puts out approximately 17 gallons per minute, okay? So if we're running the system on an average night, one head would put out approximately 340 gallons, okay? If you do the multiplication to get the whole field, on your average night during the season, if we were to water, it'd be about 27,000 gallons of water on the whole field.
Each sprinkler head is equipped with an electronic sensor and can be adjusted via the internet or by remote control.
You can adjust the spray, you can adjust the nozzles, how far the spray is going, the degree, if you want to make it 180 degree or 230 degree. You know, a baseball field has a lot of angles. You can be out there on the field with the remote and pop those heads up and make adjustments on the spot instead of running back and forth to the clock.
Whether the water at Petco Park is flowing to the field or to the fans, all of it travels through pipes tailor-made to withstand California's ever-present earthquakes.
If we look up above here, the overhead piping at this point at a seismic joint requires some flexibility. And as you can see, you see the braided flex, and you'll see the additional fittings that are there. And in an earthquake, this allows that pipe to move and not twist, break.
Most of us take high-tech plumbing systems like the one at Petco Park for granted, just as we give little thought to plumbing in our own homes. But surprisingly, most of America didn't have what we'd consider basic indoor plumbing until as recently as the turn of the 20th century. Still, its principles can be traced back thousands of years.
All the early civilizations knew that they would take the water upstream and they discharged their waste downstream. If you look at the original plumbing, that was the premise for it.
Archaeologists have discovered plumbing's earliest artifacts in Iraq, once the heart of ancient Mesopotamia. They've unearthed traces of a crude waste disposal system, primitive drains and cesspits dating back as far as 6000 BC. But excavators found no evidence of any method of transporting water to where the residents lived. 1,500 miles away, in the Indus Valley, an ancient culture called the Harappans developed an impressive waste disposal system around 2500 BC. It began with something resembling a toilet.
These structures were built of stacked brick with a seat and actually a wooden cover that went over the seat. And these then drained into, at intersections of streets, into cesspools, which had stairs so that the workers could walk down in and clean up.
By the 6th century BC, builders of the Mesopotamian city of Babylon still hadn't solved the other half of plumbing's equation: a continuous freshwater delivery system. But their method of irrigating Babylon's famous Hanging Gardens, 350 feet atop the palace walls, was a step in the right direction. At the base of the palace wall, the Babylonians built a reservoir. The water was raised by means of a slave-powered chain pump, which had 2 large wheels like a ski lift. Ceramic pots or buckets hanging from the chain were continuously dipped into the reservoir. Once water reached the top of the gardens, it could be released from gates into irrigation troughs. By around 1500 BC, 800 miles from Babylon, the ancient Egyptians took water delivery a step further, diverting it inland from the Nile for irrigation and bathing.
What they had were their artisans that were making their clay jugs figured out a way to, instead of making a jug with the bottom to it, they made it into pipe, and they made short sections. So the Egyptians were considered some of the first to be able to transport water through a conduit, through pipe.
Around 400 BC, the ancient Greeks took plumbing to a whole new level by combining the use of waste removal and water transportation devices. To deliver water, the Greeks built rudimentary aqueducts, stone-covered channels that followed the slope of the ground and let gravity do the work. To prevent enemies from sabotaging their water supply, the Greeks buried most aqueducts underground, to a depth of up to 14 feet. Once the water flowed into the city, it was held in storage cisterns. The water was then used for fountains and the ancient world's newest plumbing innovation, the bathtub. To dispose of waste, many Greeks equipped their homes with latrines that drained into a sewer beneath the street. The sewer then carried the waste to surrounding rivers.
The interesting thing is all these areas were still discharging to a watercourse. So they didn't know that much about pollution other than the fact that the human waste had an odor to it.
As impressive as these early accomplishments were, they would soon be eclipsed by the greatest society of plumbers in history, the Romans. The California Aqueduct. Built in the 1970s, this man-made river is the largest in a system of aqueducts that supply the Los Angeles area with water from the north. And at 444 miles, it's the longest in the world. The prototype of this giant aqueduct was designed over 2,000 years ago by Roman engineers to deliver water to the capital of their mighty empire. The Roman aqueduct was a milestone in antiquity's march toward effective plumbing. For inspiration, the Romans looked to their cultural and geographical neighbors, the Greeks. They borrowed the Greek concept of the aqueduct and supersized it.
The Romans are known for their aqueduct system, not because they were the first, but because they transported the water the furthest. Their longest aqueduct was in the neighborhood of 57 miles long. They were taking it from the mountains down through their piping system. Most of their aqueduct system was underground pipe. It was only when they were stretching across the valleys where they had the elevated, what we know today as aqueducts.
Once the water reached Rome, it was distributed through a grid of supply lines under the streets. The Romans built these miles of pipe with a new material they found on their exploits abroad.
They had discovered lead in England and brought the lead back, and they started forming pipes and fixtures out of lead because it was soft and malleable. Of course, the word plumber, or plumbing, comes from the Latin word for lead, which was plumbium. The use of lead was such a marvelous plumbing and engineering feat that really modernized plumbing more than what the Greeks had.
The empire's lead pipes supplied the running water that was the lifeblood of one of Rome's most treasured institutions, the baths.
According to legend, they spent approximately 1/3 of their tax dollars on creating bath systems. They were very big into cleanliness. In early Roman times, the number of baths in Rome could bathe up to 50,000 people at one time.
The emperors themselves used these baths as a means of giving the people a kind of a wonderful entertainment facility, which would prevent them from thinking of other things like political freedom, for example.
Beneath the splendor of the baths, in lower chambers, lay a marvel of engineering. Millions of gallons of water were heated by wood and coal-fired furnaces to generate radiant heat in the levels above. Wastewater drained out of the baths and other buildings into large sewer pipes that emptied into the Tiber River. For the Romans, doing their business was often a social event. Public latrines had as many as 20 seats, arranged so users could face each other. Water ran constantly beneath the seats, washing the waste into the nearest sewer.
Showers, baths, using a bathroom, group activity was considered completely acceptable, quite normal, and in fact, anything to the contrary would have been regarded as odd by them. Not by us, but by them.
When Rome finally fell in the 4th century AD, so too did antiquity's state-of-the-art plumbing.
For one thing, Rome was conquered not by a new civilization that surpassed it, but by a bunch of barbarian hordes who were basically nomads and plunderers. And they didn't really give two hoots about running water. They were never in one place long enough to enjoy indoor plumbing.
At the same time, Christianity was taking over. And of course, Christianity was concerned with the decadence of the Roman baths. So there were a number of the religious leaders that basically said that bathing was forbidden.
Medieval villagers reverted back to the simple cesspit, a hole dug in the ground where everyone dumped their waste. For centuries to come, cesspits were society's standard method of waste disposal. But they frequently overflowed, polluting nearby wells. Medieval innovators developed a new system that was no more sanitary, but a little more private. In monasteries and castles, clergymen and counts used indoor toilets known as garderobes.
The garderobe was a projection from a building, which inside contained a seat on which you sat and simply went straight down into the moat or the river or the ground below. And there are several surviving ones in England. And miserable menials would come and scrape away the dirt in the morning in grand establishments.
City dwellers, far from any moat, had to rough it by using the less discreet chamber pot.
If you were wealthy, a chamber pot would be an ornate ceramic bowl, big enough for you to squat over.
When the chamber pot was used, it was thrown out into the gutter, so there was really no sanitation at all.
People began crowding into cities in the Middle Ages, and these unsanitary conditions triggered waves of deadly epidemics.
Everybody knows about the bubonic plague, or the Black Plague, But there were a number of other smaller plagues that took place because dysentery and typhoid were rampant throughout Europe. And one of the reasons for that was the unsanitary conditions. They knew that there was a malodor and it was terrible and it smelled, but they didn't know that it was creating the disease.
By the end of the 15th century, Europeans began to suspect that there might be a link between their crude waste disposal methods and the diseases that plagued them.
So it was at the end, what we say during the Renaissance era, that we started to see the revitalization of plumbing because of the starting to understand germs and bacteria.
Europeans who could afford it now had servants cart their waste away. One enterprising Englishman went a step further. John Harington, the godson of Queen Elizabeth I, recaptured antiquities concept by devising a way to let water do the work. His invention marks the origin of the modern toilet, aka the John.
It was a very primitive type, and he put it in Queen Elizabeth's I castle. And it was one of the first functioning water closets that they had water in it, and it would flush.
Harrington's contraption had a tank filled with water and a valve that released the water so it could flush away the contents into a cesspit. But it was missing a crucial third element, a way to prevent the putrid cesspit gases from wafting back up through the toilet. Ridiculed by his peers, Harrington produced just 2 of his toilets. Almost 2 centuries would pass before a new generation of innovators would take up where Harrington left off and transform his invention into a household word. Few of us give much thought to the plumbing networks in our own homes. They run unnoticed, hidden behind living room walls and buried under foundations. We pour a glass of water, do a load of laundry, take a shower, all without thinking about how the water comes and goes. But the plumbing pipes are the essential veins and arteries that make a house a home.
The cost of a home, about 17% of it is the cost of your plumbing system. So that puts it into perspective. There's quite a bit of amount of pipe.
Although American houses come in a variety of shapes and sizes, the plumbing system in each of them has the same basic elements. Pipes for incoming clean water, pipes for outgoing wastewater, and pipes for venting air. Every system is installed in phases, beginning when the foundation of the house is still exposed. First, workers piece together the primary arteries for incoming water and drain pipes to the sewer. After workers erect the frame of the house, plumbers begin installing the plastic PVC pipes that will carry wastewater out of the home and into the sewer drain pipes. PVC piping is also used for venting. Each plumbing fixture is linked to a vent pipe. Venting allows foul-smelling sewer gas to escape while ensuring smooth water flow.
The purpose of a vent is to have atmospheric pressure equally inside the plumbing system as we have on the outside, so we always have a free flow. A perfect example would be drawing up a liquid into a straw, putting your finger over it, the liquid will remain in there. That's a closed system. Take your finger off, that opens it up, allows free flow, and that liquid will flow out very easily.
After the vent pipes are in place, plumbers run copper piping to each fixture that requires an incoming supply of potable water. Over time, stronger copper pipes will withstand the pressure of incoming water better than PVC pipes. Separate lines are run for hot and cold water. Unlike PVC pipes, which can be glued together, copper pipes must be soldered. After all these pipes are installed, the primary or rough plumbing is finished.
Once this has been inspected, then drywall goes over this, it becomes painted, and the end user, the homeowner, they never really get to see what's behind the wall, and eventually they hang a picture of grandma up here and everybody smiles, but behind it, that's their plumbing pipes going up to feed the hot and cold water up there to the master bath on the second floor.
100 years ago in colonial America, the only pipes in houses were the kinds that men stuffed with tobacco. Colonists didn't think too much about indoor plumbing, mainly because they didn't see a need for it.
Cleanliness was not a treasured value of colonial America by and large. People rarely bathed. They rarely took baths. They might do so once a month, a couple of times a year.
Even so, as the colonists built their cities, running water was a high priority, not for bathing, but for firefighting. In the mid-1600s, workers in Boston built America's first water system to supply firefighters. They joined hollow logs together to create a water main. To access the water, firemen would simply drill through the walls of these primitive pipes and plug the hole when they were finished. When it came to waste disposal, the great outdoors proved an appealing alternative to the old country's chamber pots. But before long, Yankee ingenuity gave birth to an American institution, the outhouse.
Outhouses were basically the bathrooms of the early colonial settlers in this country, and some of them were quite ornate.
The technology was simple enough: a deep hole in the earth, a seat, and a wooden shed with a door. Outhouses continued to proliferate throughout the 19th century in America, well beyond the advent of the indoor toilet. With independence came innovation. And by the mid-1800s, Americans began to bring plumbing indoors.
The homeowner would build a cistern and place it in the attic of the house. The water would be pumped up into that cistern from some external source. The water would flow by gravity from this cistern into a variety of devices.
In the following decades, one of these devices would be an improved incarnation of John Harrington's breakthrough invention. Across the Atlantic, innovators in England began flooding British patent offices with updated versions of the water closet. Many models incorporated a new trap seal mechanism. In theory, the trap seal was an effective solution to the reeking odors that wafted up through Harrington's toilet. A U-shaped section of pipe beneath the drain and toilet bowl used a simple law of physics to create a water seal, blocking sewer gases from entering the home. But the trap seal by itself wasn't enough. The answer was venting.
What the vent does is allow air to come into the drainage system, so when that water falls, the air goes with it, and it doesn't suck the water out of that trap. Very, very simple.
In the late 19th century, with the principle of venting applied to the water closet, a revolutionary precursor to the modern toilet finally emerged. But identifying the inventor of the toilet is a bit tricky. The most controversial figure in the history of plumbing had a name as fitting as it was farcical: Thomas Crapper. When this biography of Crapper was published in 1969, many believed it was a hoax. Did Crapper actually invent the forerunner of the modern toilet? Did the man really exist? Even today, those who are privy to Crapper's story continue the debate.
Originally, the thing that Crapper developed was called the water waste preventer. And if you lift the lid of your loo now, it's exactly the same as when he developed it 100 years ago.
Americans cannot get over the fact that there was a man selling plumbing fittings with a name like Crapper. Now that's amusing, and it's great, and it's fun. But that he invented the loo, and he had anything to do with inventing the loo, is, I'm afraid, a myth.
James Watt didn't invent the steam engine, he just made it work. Marconi didn't invent wireless, he just made it practical. It's the same with Crapper. A lot of people were working on it at the time, and he made one that worked.
The WC pan, which is universally recognized today, was designed by Frederick Humpherson in 1884. That's my great-uncle, Frederick Humpherson, and this is the famous WC pan, the Beaufort, the first pedestal wash-down closet.
In the mid-1800s, as water closets were making a big splash in Western society, so was an unprecedented abundance of sewage. the cities of Europe were the first to pay the unseemly consequences.
What finally happened is you had places like London where the Thames was so filled with sewage and the malodor, and Parliament meets right on the Thames River. So Parliament could not stand the odor. It was so bad that they could not meet. That's when they started to pass some of the bills to address the treatment of the sewage and try to transport it away from these main watercourses.
In 1858, London's newly formed Metropolitan Board of Works undertook a historic project, the construction of London's first sewer system, designed to carry the waste away from the city. During the same decade in Chicago, workers built America's first integrated sewer system. But the young city was facing a contamination problem that sewers alone couldn't solve. Increasing quantities of raw sewage were being dumped into the Chicago River, the only viable conduit to carry away the enormous daily flow of waste. But the river emptied into Lake Michigan, the city's only source of drinking water.
As more and more people started coming into the city, they had to take those water intakes and move them further and further into the lake. And for a while, it worked. But then in 1885, there was a tremendous 4-day rainstorm that just flushed all these primitive sewers way out into the lake so that the water intake cribs were inundated with this polluted material. 25% of the entire population of the city of Chicago perished from waterborne diseases during that time: cholera, typhoid, etc., dysentery.
Chicago now faced a nearly insurmountable problem. The answer was a mind-boggling feat of civil engineering. Workers constructed a 28-mile canal connecting the Chicago River to the Des Plaines River, a tributary of the Mississippi. This reversed the flow of the Chicago River. Its water now flowed away from Lake Michigan, preventing sewage from entering it. The ambitious project, successfully completed in 1900, would serve as an example for other American cities. They too were coping with the growing popularity of indoor plumbing and with ever-increasing amounts of sewage. A new generation of plumbing students, with pipe dreams of becoming masters of the craft, is clogging up the industry's training facilities. The local 501 training school in Aurora, Illinois, includes a mock-up of a 3-story house, offering a hands-on education that some find a little draining. Each student must complete a 5-year program, which includes an apprenticeship and a state exam. The facility certifies up to 90 trainees as plumbers every year.
I could make an installer out of anybody. They could install pipes and have no concept of why they do what they do, or why it fails and why somebody would get sick. Whereas in here, we teach them the science, we teach them the physics, the math, and all the things, the mechanical aspects that go into the industry to make them a professional.
If one message rings loud and clear with the students here, it's that the critical measure of any plumbing system is its hygiene. They're trained to adhere to state and federal laws designed to provide people with both a safe water supply and an effective means of disposing waste. The origins of such safety standards date back to the U.S. Civil War. A sanitation crisis arose during the conflict, as more soldiers were dying from waterborne diseases, like dysentery and typhoid, than from battle injuries. Later, government studies proved that such diseases could be traced to bacteria in contaminated water supplies and waste inadequately discarded.
In the late 19th century, especially after about 1890, Americans finally accepted the germ theory. And the reason we have stark white fixtures made of porcelain now is because of this crusade to create a germ-free environment. The bathroom now became this almost hospital-like environment, completely tiled, no wood, all of the pipes exposed.
By the 1920s, architects were designing such antiseptically conceived bathrooms into new homes as standard features, along with hot water heaters and fully plumbed kitchens. bathtubs and toilets could hardly roll off assembly lines fast enough to satisfy the demand of hygiene-conscious consumers. Manufacturers helped feed the frenzy.
Starting around 1920, an old industry magazine started publishing a campaign for a bath a day in American society, and over 100,000 pamphlets were distributed to schools and to plumbing customers throughout the United States, urging them to take a bath a day.
The plumbing boom wasn't without setbacks, however. Substandard plumbing continued to trigger outbreaks of deadly waterborne diseases. At the 1933 Chicago World's Fair, sewage from toilets backed up into the clean water supply, sparking a dysentery epidemic that killed 98 people. This and other seemingly avoidable tragedies compelled civic leaders to call for plumbing industry regulations.
And cities began to pass plumbing ordinances dictating exactly how things could be attached in your house, exactly right down to the size of the pipe that you could use, exactly what kinds of fixtures you could use, how they should be installed, where they could be installed.
The era of the professional plumber had arrived. Industry leaders formed professional associations and instituted formal apprenticeship programs. All the while, plumbing technology continued to advance. In the 1930s, innovators at the Watts Regulator Company devised a sorely needed gadget for America's water heaters. To this day, the company manufactures this essential component. It's known in the trade as a T&P valve.
Without a temperature and pressure relief valve, the pressures inside of a water heater can build up to the extent that your water heater may someday take off and end up in a neighbor's house maybe a quarter mile away. These things used to happen quite commonly in America. They still happen once in a while in homes where the water heater does not have a T&P valve. But this was a great invention, and I'm sure has saved untold lives in America, and most people don't even know they have them.
By the 1950s, with the help of a few critical inventions and a lot of laws, America had overcome the hurdle of creating safe and sanitary plumbing for its citizens. The plumbing students in Aurora, Illinois, are learning the basics of preserving that standard. Part of their curriculum includes the opportunity to install the growing variety of plumbing fixtures in their unusual classrooms.
We're standing in the mock residential house that we teach our residential plumbers how to install normal residential plumbing, waste and vent, water pipe, setting tubs, things like that. The basic stuff they're going to do every day out in the field.
The school has another specialized classroom, the so-called wet lab. Here, students get up close and personal with the inner workings of all kinds of plumbing fixtures. One special display illustrates how water-conserving toilets can flush with the same gusto as the old 3.5-gallon models.
What you'll see is that 1.6 gallons of water will take, say, a half dozen golf balls and slowly convey them down this waistline. And we run it in 4-inch clear plastic so that the apprentices can see both how pitch, as far as the slope of the pipe, and the quantity of water would carry solids down a drainage system.
What's in plumbing's future? Some innovative fixtures are poised to shower us with new pleasures, while others place yet another remote control in the hands of the American male. The safe sanitary plumbing in your house is one of those technological triumphs you never really appreciate, until something goes wrong. When that happens, you can call one of the nation's 300,000 plumbers.
Our typical calls are throughout the day are generally your drain cleaning, but we have about 50% of our calls are also repair plumbing. Water heaters, sewer line replacements, slab leaks, drippy faucets, garbage disposals, that kind of thing.
Today, plumber Don Hatcher's challenge is to replace some leaky pipes buried beneath a suburban yard. In the past, the conventional approach required a lot of destructive digging. But now there's a better way. So-called trenchless technology enables plumbers to toss aside their shovels and insert new pipes directly inside the old defective ones.
What we're going to do is we're going to feed a cable through the line, and actually pull a stainless steel bursting head through the line, and right directly behind that will be a new polyethylene pipe.
Even as we shell out the dollars to keep our old plumbing systems working, we can also indulge in shopping for the industry's latest cutting-edge fixtures.
This has a waterfall shower head above. If you ever wanted to sit under a waterfall, this has the perfect sensation of doing that. The water is pumped out of the reservoir on the bottom here, up and out either to the body sprays or to the waterfall there. This is the latest in toiletry technology. You can flush it remotely. You can raise the one seat. You can raise the second seat with the remote. And you can also control all the bidet functions with the remote as well. Once you're done with the bidet cycle and you turn on the dryer, that dries your bottom while you're still sitting there.
While plumbing designers continue to dream up fashionable fixtures, they must also consider the profound issues facing the industry. The greatest, perhaps, is a concern shared by municipalities around the world: water conservation.
Somebody such as myself who may be discussing plumbing history 25, 30, 40, 50 years from now may look back and define one of the watersheds of plumbing history as the 1992 Plumbing Products Efficiency Act, which involved the federal government mandating that no toilet will flush with more than 1.6 gallons of water. The previous standard was 3.5 gallons. They also put restrictions on flows of faucets and shower heads as well. I think it's the first step of what is going to be a continuing trend towards making plumbing products more environmentally friendly.
To meet the monumental challenge of conserving the world's precious water supply, the plumbing industry is taking bold new steps. As shocking as it sounds, scientists are conducting experiments to introduce recycled wastewater into potable water supplies.
They can treat any kind of water. The dirtier it is, the more it costs, but you can treat it. And then they've also established processing treatments for water treatment, so that literally you could take this sewage water very shortly and use it for drinking water.
If such technology prevails, the future may bring us full circle to the ancient past. As it was in the world of our ancestors, the distinction may blur between the water we drink and the water we use to discard our waste. What separates then from now, however, is advanced technology that makes such a reality safe for all of us.
History has proven that plumbing, sanitation, both in waste removal and in potable water, is at the forefront of safety and health. And that there has been nothing greater, no medicine, nothing yet to date that protects us better than sanitation.
Plumbing. In many ways, it's out of sight and out of mind, something we consider only when a sink backs up or a toilet overflows. But it's a marvel disguised as the mundane and a cornerstone of humanity's health.